This video will provide a technical overview of how Charli3's decentralized oracles work, using a single price feed for the current price of ADA, measured in US dollars as an example. The foundation of our oracles are the Charli3 nodes, which consist of the Charli3 node engine being operated and maintained by independent node operators. These nodes aren't controlled by Charli3 directly, and can be operated by anyone with the right expertise. Having multiple independent nodes in this manner adds a layer of security, as the decentralized nature of it means that it takes much more than a single bad actor to manipulate the value of the price feed. The person setting up the feed is able to control which node operators are able to provide data for the feed, allowing them to get a level of security they need for their feed. Each individual node monitors the target data, in this case the price of ADA. Whenever the price changes a significant amount, or a set amount of time has passed, each node sends the current price of ADA onto the blockchain. Once a sufficient number of Charli3 nodes have updated their data values on-chain, an aggregation will be triggered. Not all of the nodes need to have provided updated values to allow for an aggregation, only enough of the majority to get a good sample size. This keeps the oracle robust against downtime of individual Charli3 nodes, and incentivizes nodes to provide updates as quickly as possible. The aggregation takes all the updated values and compares them to one another. This way, values that are wildly different from the overall consensus of the nodes can be discarded, to secure against bad actors trying to manipulate the feed. Charli3 nodes that provided updated values for this aggregation are compensated for their work by receiving a certain amount of Charli3 token, C3. This entire aggregation happens on-chain, meaning that the input and the output can be inspected at every step of the way, making the process transparent and auditable. Once the aggregation is over, a new data value is produced, in this case the ADA price that all the Charli3 nodes can agree upon. This value is stored in multiple independent UTXOs that are ready for consumption by the feed users. For example, a decentralized exchange that needs the current price of ADA in US dollars. Storing the oracle output in multiple UTXOs in this manner helps us to avoid throughput issues, as each UTXO is available to serve as a separate transaction within the same block. This process repeats itself over and over again for each individual Charli3 oracle feed on the blockchain, with Charli3's decentralized nodes serving each of them.